Alright, so right over here, let's look at the second part of finding the error between two curves. Right, so this is still math 141. Right, so in that case, we're just looking at the area. Right, so looking at the area, right, so right over here, from the first place, the beginning of this session, right, of this lesson, we looked at the curves top minus the bottom, right? But in this one, you're going to be looking at the curves. So this is a curve and that is the curve. And then what about the bounds from C all the way to D, right? So this is what you're going to have. Now, how can you find this area bounded between two curves, right? So this is your f at y, and that is your g at y, okay? So this is what you have. It's the same procedure, but right now we just changed those bounds, and then you just change everything, right? So in this case, the method that you have to understand is that the area is going to be equal to right minus left. This is what you're going to have to understand. Right over here, A to B. So right over here, we were saying, okay, fine. To find the area right over here, what we have to do is just going to be like, okay, the area is going to be the top minus the bottom. This is what you have to do right here. But in this case, it's going to be the right minus left, right minus left, right minus left. In some other cases, you'll find it difficult for you to see which one is on the right, which one is on the left. Just draw a horizontal line. So the first one to touch, that's one on your right. Okay, so which means right here, area is going to be equal to, it's the same procedure, right? So it's going to be integral from C to D, right, of f at y minus g at y. And then there's going to be dy. Remember that, because right now this is f at y, this is not f at x, okay? So it's f at y. So that is the equation, right? If you have curves, that's another method, right, to find the area between two curves. But now, yeah, some other time you'll have to use this method, some other time you'll have to use this one, right? Depends on the curves, right? The shapes of the curve, okay? Alright, so let's look at the example right over here. So they're saying right over here, this is example number 2. Right, so they're saying find the area of the region enclosed by, we have x is equal to y squared, and we have y is equal to x minus 2. Now remember this. So if they didn't give you the bounds, remember that on our first example, we had the bounds, okay? X is equal to 0 and x is equal to 2. But in this case, they didn't give us those bounds, right? But you'll have to find those bounds, okay? So in that case, in order to find the bounds that you must have, so you just have to equate your curves, and then you'll find your point of intersection, okay? That is going to be your bounds. So right over here, okay, so we're going to have to equate these. So the good way, let's just choose y. So we're going to say y squared is going to be equal to y plus 2, right? And then this will be y squared minus y minus 2 equals to 0. Just solve that real quick. It's going to be y minus 2 and then y plus 1. Is that correct? Yes. It's equal to 0. And then y is equal to 2 and y is equal to 1. That's negative 1, by the way. Okay, so this is what you will have, right? These are the bounds that we need, because right over here we're looking at the second method from C up to D, right? So from C up to D we talking about y bounds. So in this case we've got y's, right? So y values, so it's not a problem. Okay, so which means right over here there's no need to sketch the curves, right? Because we know that this one is going to be at the top, this one is going to be at the top, and this one is going to be at the bottom. Right, so yeah, you can sketch that and you will see that. Okay, so which means right over here the area is going to be equal to integral from minus 1 up to 2, right? Because from C to D, not from A to B, C to D, right? So we're going to say top minus the bottom, right? So the top one is going to be y plus 2, and then minus, then the bottom one in parentheses is going to be equal to y squared, right? We have y squared right over here, yes. And then there's going to be a dy. This is what you will have, okay? So we can try and simplify that. Area is going to be equal to integral from minus 1 to 2 of y plus 2 minus y squared dy. Area is going to be equal to, I'm just going to do this real quick. y squared divided by 2 plus 2y. Again, this is all maths 131. Okay, you must know this. You must know how to do your definite integral. If you don't know how to do that, go back to your 131 and practice more. And then you will have to substitute your bounds and find your area. Okay, so here is going to be equal to that.